holy shit. Why not do Waller's weird thing? Do all this, calculate x p of x, calculate x squared p of x, but we already know what the answer would be for the standard deviation. It would be, if I took samples of size 3, and I did all this work, it would be whatever the hell 1.18 divided by the square root of 3 is. That is too beautiful to believe. Because I don't want to do more than this. This was bad enough. So can you imagine taking samples of size 50? Do you understand how big samples of size 50 would be? 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 2. 1, 1, 1, 1. Holy shit! But I don't have to. I've got this theory that seems to be borne out with what we've done. I just have to divide by the square root of 50 then. And then I already know what the standard deviation would become. That's too nice to believe. So I think, oh man, let me do one last thing. And you're all like, it's your class, dude. Yeah, let me do it on here. We'll talk more about this next time, but just to give you a feel for this. If I went to Florida, let me say I go to some island. Florida almost works for this, but not quite. And I ask people how old they are. And I get a distribution of ages that looks like this. So what this means is there was nobody in here, right? Mm-hmm. So maybe there's a lot of people from 0 to 35, and then from 55 up to 100 or whatever, right? I know my scale sucks, I don't care. So how did I create this? I would go to that island, I would say, how old are you? And then they would say, I'm 18, and then I would put a dot. Mm-hmm. Then I'd say, how old are you? And they would say, I'm 2, and you put a dot. How old are you? I'm 97. Okay, put a dot, right? And I just keep going. And I just keep going, and eventually some people are the same age, so they build up. Do you guys see how this picture's made then?
Yeah.
By recording individual ages. What if instead I went to this island? So this is n equals 1, right? Let's say the mean looks to be, what does it look to be, 45? Mm-hmm. Right? And does it look like anybody's within 1 standard deviation roughly? It looks like nobody is, right? Mm-hmm. Now, what if instead I went to this island, the same island, and I took groups of size 10? And then I didn't put a dot until I figured out the average of that group. So what is the most likely thing to happen if I took a group of 10 people from this island? Is it very likely that I get 10 people right here? Think about it. Is that really likely that I get 10 people right there? No. Is it really likely I get 10 people right here?
No.
No. What is the most likely thing to happen? Some from... 1 minute.
Sorry.
That's all right. Some from both sides, right?
Yeah.
I like it. So what's the most likely result for any sample is going to be actually this mean. Mm-hmm. So this new picture is going to look like this. Oh. This should be the most likely thing. Mm-hmm. And then I'm going to actually get like a little bound here probably for this guy, because the next most likely thing is a bunch of stuff here, and then a little mound for this guy. All right, that's obviously not perfect, but does that look normal? No, but does this look more normal than that did? Mm-hmm. Yes. And then if I made 30, it's going to look normal like that. We'll do more of this next time, because this is important. This is the idea behind the math we just did. Mm-hmm. Yeah.
Then just to clarify, so in this case, n would be the number in each group?
In each group, each sample I took, yeah.
Okay.
Yeah. And by the way, real quick, the standard deviation here would be smaller, right?
Yeah.
You see how more data points are close to the mean? Here, there's nothing close to the mean. All right, that's good. That's
okay. Huh.
What's up?
I messed up with those. I knew, but for some reason.
Oh, okay. Yeah.
So, how much did I get?
5 points.
Just 5?
Next Wednesday, chapter 5 and 6.
Yeah.
Oh, I'm still recording. That was exciting. Bye, everybody.